Now we're going to rationalize denominators. It's a procedure used to make the denominator a rational number by eliminating radicals from the denominator. No radical allowed. Now, in my first problems here, I do see radicals. There's a radical square root of 5 in the denominator. So the easiest way is multiply by the radical, top and bottom. That's equal to 1. So I'd have 2 square root of 3 for the numerator. Square root of 3 times square root of 3 will give me 3. That has been rationalized. Oh, that's not too bad. Let's try this next one. I'm going to multiply top and bottom by square root of 6. That gives me 15 square root of 6 over, that would give me square root of 36, or square root of 6 squared, or square root of 6 times square root of 6. It's going to give me 6. So there's a couple of ways you can look at that, but think that you are squaring this, which undoes the square root. But now be careful. If you'll notice, I've got a fraction here that I can reduce. I can divide top and bottom by 3. So that would be my simplified answer. In this one, we'll multiply by square root of 5 over 5. Up top, I've got square root of 15. On the bottom, I'm going to have square root of 25, or 5. I cannot reduce this. This is under the radical. The only time I can reduce is if they're together under the radical or they're outside of the radical. So I've got a few more problems. Now if you'll notice with these denominators, there was nothing I could do. So that leads me up to the next problems I need to look at. So I need to simplify and rationalize the denominator. Now earlier I said there was nothing I can do with those denominators because they did not contain a perfect square factor. But both of these do. So let's simplify first. So that would be 4 times 2. That would give me 12 over 2 square root of 2. So right now I have got this. But I need to multiply top and bottom by square root of 2. So it gives me 6 square root of 2 over 2. And I can simplify again. There's a number of ways you can go about this, but you should eventually end up with the exact same thing. I'm going to simplify my denominator first. And now I'm going to multiply top and bottom by square root of 3. So that would give me square root of 21x over 5 times 3, 15. And that will be it for that problem. So the last 5 problems we've had, there's just been a single value in the denominator. Now in example 3 and example 4, they tell you what you need to do. If you have a binomial, you have to multiply by the conjugate. And you just change sign. In the numerator, do not do anything. Leave as is. Sometimes something happens, so do not multiply this out. We are going to multiply out the denominator. First times first, that will give me a 25. Outside is a negative 5 square root of 3. Inside's a plus 5 square root of 3. Those eliminate. I'm going to have a minus. I'll always have a minus here. Square root of 3 times square root of 3. That will give me a... So my answer for this one would just be 7. 5 minus square root of 3 all over 22. So that would be my answer for that one. And the denominator has been rationalized. Let me look at this last one. Write down what you think the conjugate is. You need to pause me, and we'll see if we agree. And hopefully you got that. Up top, remember, do not multiply that out. Just leave it. In the bottom, that will give me square root of 6 times square root of 6 is 6, minus square root of 2 times square root of 2 is 2. And this was what I was talking about. Something nice sometimes happens. If you'd multiplied that through, then you'd have to come right back and factor it again. So don't multiply those, because a lot of times that does happen where you can reduce the fraction. Okay? That's it for this video about rationalizing denominators. Thank you.